This question is from page 317 in the Barron's workbook, number 4. It asks to find the bounded area between the parabola y squared equals x, which I've drawn in purple here, and the line x plus y equals 2, which is a black line. Now, to do this, that area that we're looking for is the yellow area. And to do this, we could do this two ways. We could find rectangles vertically like this, and above and below the curve, we have to split the bounds because we have a curve and a straight line. So we have two different equations to work with here, and above and below that we have to work with. But it could be done with x's, with dx's. But I'm going to propose something different here. So instead of using vertical rectangles, I'm going to use horizontal rectangles. And if I take the width of that red rectangle and multiply it by the width of dy, or delta y, the change in the y values, that will give me the area of that one piece. And what I can do then is integrate from -2 to +1 and work out the area that way. So how do we set it up? Well, the first thing is I want an x length, so I'm going to set up my two equations as x equals. So the straight line becomes x equals 2 minus y, so I've labeled that x1. And the other equation is going to be x equals y squared. I've labeled that x2. That's the purple line. And if I want to find the width of the rectangle, so the width of rectangle, that's going to be the black line, or 2 minus y, the x position of the black line minus the x position of the purple line, which is y squared. And that difference will give me the length, the horizontal length. Now, if I want to then find the area, I'm going to multiply by delta y and then add it up. So that is doing an integral. So that area can be done by integrating from y equals -2 to y equals 1. And it's going to be finding the area 2 minus y minus y squared, and taking that width that I found here. Actually, I'm just going to write that in red. So 2 minus y squared, that represents the width of that rectangle. And then I'm going to multiply that by dy. And that red represents the rectangle. The integral represents the summing up those rectangles from y equals -2 to y equals 1. Now, if I take a look at that, it's consistent with y, so I'm integrating y's with dy's. My bounds are in terms of y, so everything is consistent, so this should work. So I'm going to go ahead and anti-differentiate this. So I'm going to get 2y minus y squared over 2 minus y cubed over 3, and I'm going to integrate it from -2 to 1. I'm going to plug in my bounds here. So plugging in my bounds, I'm going to end up with 2 minus 1/2 minus 1/3 minus, so plugging in -2, I get -4 minus, plugging in -2, I end up with 4 over 2, so -2 minus, plugging in -2, I'm going to get negative, so that's going to be positive 8 over 3. And then summing this all up, I'm just going to sum up maybe the whole number parts here. So these whole number parts, if I sum that all up, I'm going to end up with positive 8. And I'm going to sum up, I'll just do that part separately. So minus 1/2, and then -1/3 minus positive 8/3. That works to minus 9/3, which is -3. So then the total area that I get is going to be 9 over 2, or 4.5. So that net area works out to be 4.5 units squared.